That's mainly for people, if they didn't make it to class or whatever. But it should be on the UJA if you want to review that part. If not, let me know. Anyway, I'm gonna just make one big recording because I figured out how to get that loaded up into the YouTube channel with just even a 2 hour thing. So, all right. So I'm gonna create a new plane and call it back pocket. So you can put it in your back pocket. Enter. And you can go on your plane manager. And since this is going to be a lot like my other plane, I'm just going to pretty much spin my Y around again. I'm going to right click and say duplicate, and it'll make another plane just like that one. And then I'll just have to spin that around to alter it, sort of. So let's see, rename, back pocket. So I've been working with our lathe guy at Procon to get our post right, because man, we had to make a lot of alterations on our post process. I mean, it's worse than this one. So I think there's just not a lot out there because a lot of companies will have them custom done in a custom way. All right, so when I want to edit this, it's a lot easier in wireframe. I'm going to say edit, and the only thing that's going to change is my Z position. So for whatever reason, it's pointing the opposite way. 180. All right, so back pocket, 180. Perfect. I'm going to make sure my graphics window is there. And it's funny because it puts it on the opposite side. I think it's because it's got it spun around this way somehow. But I'm going to say save this view sheet. So anytime I'm on this tab, all my operations are going to be based on this work plane. So if I wanted to go back and work on the main Y step, which has a new orientation, resave it, I would just simply click on the view sheet. So that's what the purpose of these view sheets are for, is to correctly orient your toolpath with your operation. Because you might have a part that you're working off of in two vices, and you'd have G54 and G55, and you might be wanting to cut those two parts at the same time, just in different vices with different operations, because you might want to just pull out your spot drill once for both parts. So you can do one spot drill op in your one tab, come over here and do your next spot drill in your other tab, and it will automatically set your work offsets for you. One thing you have to do is tell it, oh, I want the back pocket to be, work offset number 1. And you click on it. So that will input your work offset into your toolpath as well. I'm going to leave it automatic for now. And we're going to work on this back pocket. It's kind of weird because it's turned around. I'll probably dawn on me later what I'm doing wrong here. So I tried doing a contour on this last night, and it turned out to be kind of a big mess. And so I found that one of the better toolpath was going to be a pocket toolpath. And the problem with this pocket toolpath is that we don't have any geometry to really go off of. Sorry, that's so erratic. My mouse wheel is not acting right. Because when we come around this surface here, we essentially don't have a closed chain. It's an open chain. So what we have to do is go into our, let's just click on bottom. Graphic view, bottom. That's interesting. top. Yeah, I'm a little confused on what it's doing here, but as long as we're outputting good code, we don't have anything to grab on here. So I'm going to go into my levels, and I'm going to say, all right, we want to probably do the same level as a turn boundary. And we would have to create a silhouette boundary based on this geometry. So back again, if you remember, it's wireframe, silhouette boundary. And I just want to see how it kind of changes colors on this little area. See, that's not what I want. So it's set on select the whole model. Escape. And let's go try that again. Silhouette boundary. And right now it's on solid selection, so we need to go to turn that off, and it lets us pick this surface. So there's a lot of really kind of important elements here. I guess we could pick these surfaces too. Hey, that's nice. That's going to save us a lot of time. So what we're doing is we're creating 2D geometry, wireframe geometry based on this 3D solid geometry. Say green check. So it's processing all this, but you can't see anything, right? It's because our 2D geometry is in the middle of the part. It's a really great reason to put this on a different level. Yeah, that was weird. All right, so I'm going to go to planes, which I'm in. I'm going to turn off YC project, and now you can see our 2D geometry. Now these annoying toolpaths that are left over, you can get rid of those by saying Alt-T. Another thing you can do is in your toolpath manager, make sure, see, it's only showing that because that toolpath is selected. This is select, only display selected toolpaths. So if I was to pick this one, it would get rid of that. But it would be showing the turn boundary that you can't see because it's on a different view. Really need to be on top view now. Because what I'm going to do is I'm going to chain this geometry and tell it we want to cut a pocket. Pocket toolpaths, that's one reason I like to use mill toolpaths for this is because you have all these options. We're going to cut a pocket. Pocket is basically anything that's a closed chain that's a pocket. And anytime you select a closed chain and it all lights up like that, that's good. Because if it only lights up a little bit or part of it, it means you got a problem with your geometry. And what we'll do is we'll try to make several different little chains and not cut it correctly. But this is pointing in the correct direction. And we're going to use our same. So here's your chain geometry. If you want to go revisit it, you say, there it is. And this will let you edit it. You can add chains. If I wanted to add a chain up here, which I'm probably going to do because if I wanted to add an entry point, you would create a point in the middle and hit that point first. But with pocket toolpath, we don't care. It's already created something here, but I don't want it. So our chain geometry is good. Okay, leave that alone. We use our 1/4-inch flat end mill, and our values are still, no, see, it popped it down to 139 surface feet again. Even though, so that's kind of maddening sometimes. I haven't quite debunked that problem yet. We're at 300 here, and there's no apply button or anything. It just leaves it there. We'll just change it 280 or 300 or whatever it was. 25 inches a minute. Plunge. I'm just going to plunge at 25 also because we're probably going to be doing a helical entry here. So with pocketing, it gives you a couple different options. Oftentimes when you're working in Mastercam and you're not seeing the options you want, it's okay to just go find a different toolpath. Sometimes I'll try 2 or 3 before I settle on one because if you can save 20 minutes on a run of 150 parts, that's a 40-hour work week. So standard. I'm not going to leave any stock. Yeah, climb. So I like true spiral. These are all your different options for how it's going to rough it out. Step over, you can control that. Tolerance, blah, blah, blah. So here's what I like a lot about the pocket is you can do a helical entry so you don't have, or a ramp. Give you options of what your ramp length is. Your helix is really cool because it just helix bores right into it. And so you don't care if you're end mill center cutting or not with this feature. Finishing will take one pass, 10 thousandths. Cutter compensation. I'm going to leave that computer. Keep tool down. Finish only at final depth. We'll see how that goes. Lead in, lead out. I'm going to make this like 15% and this 40. And so what that'll do is it'll force it to turn the comps on in a linear move. Because as we all know, Haas does not like arc. And now if you had a special point that you wanted to use, you would click enable use entry point, but we're just going to kind of see what happens here. Linking parameters. So all this again, we want this to be incremental. And our part's 2.1, so this should be like, well, from the surface anyway, 3 point for safety. Top of stock, I'm going to leave an absolute, and depth, I'm going to leave an absolute, but I'm going to pick it off my part. So let's come back in and turn my solid back on and my levels, or it won't let me pick it. It's on the opposite side. And I want to make sure we're on the right plane manager, and we're not. So if you pick a feature in the wrong plane, it's going to put it at the wrong spot. So I think we're selecting the top of our part right now. There. See, now it's weird because it's saying minus 1.050, which we know is not true. And something's not quite right with this. So we have to go to the other side. Pick this. And now it's going to say 1.050. Our depth, I think we're just going to have to override, but we can still pick it because it's going to tell us it's minus. So if it's on the other side of the part to get our Y's to cut right. So just make that plus at 0.850. And our filter tolerance. This is where you want to enable your arc filtering because this will allow it to output arcs and circles. And I will usually throw this all the way to the right. It tends to make a smaller file. Planes. So we're on back pocket. So this is part of the problem. We're probably gonna have to go back and reselect everything. Should have done this first. We need to be top. And then this needs to be our back pocket plane. So that's probably what the problem is. It's stuck in the wrong plane. So we'll go back. I think our linking parameters will be the same, but now we can pick them where we want, or we should be picking them. Nope, did the same thing. 1.050. Not real sure about that. Something squirrely here, but we'll see what it outputs. Coolant. Ignore. Turn that on. Our can text. Leave a little miscellaneous values. We're going to make sure this is 0 because we're not using polar milling, which we're going to talk about next, by the way. And make this y-axis. Now we should have a y-axis toolpath. Regenerate. And it's cutting it on the wrong side. fine. See, I only spun that around because it was cutting this one on the wrong side. Seems like we have had this problem with the Procon lathe thing. So I guess we're just going to have to leave that gnomon the same. But likely it's not going to generate the correct rotation in our Mastercam file, and we'll have to manually change it. Unfortunately. So we'll edit. And let's just spin this Y around. Or spin the Z around 180. Which means hopefully we can just regenerate it and move on with our lives. Alright, so you see this cool toolpath that it created. It's going to come in here. Let me turn my solids back on. Alt-S will do that too. Come in here, wind on in. It's going to cut our path from start to finish. And that way we can go on with our lives. Watch this whole thing run and verify. I do encourage you to try this with your home learning edition. Now you won't be able to verify it. Okay, now even though this part is embedded seemingly in the material, it's not a crash. It does weird things when it's... Oh no, that is a crash. Is it because... Why is it? I think we screwed it up when we changed the plane manager. So let's go back in here and reselect some things. Top of stock. Yeah, something's kind of wonky. See, now that one's on the opposite side. Escape. So let me just try this one more time. I guess we'll have to live with the Y's being backwards. Main Y step. I'm going to edit this. And we'll spin the Z around 180. So it does need to be pointing towards the tool orientation. And we'll regenerate that. So notice it only made the toolpath dirty that was associated with that value, with the plane. All right, I think we got it fixed now. So let's go back and watch it. And verify. I just didn't want to leave this project with a crash. It's still crashing. Oh, the tool change. Okay, now it's going to cut it. Just the Y's are backwards for some reason. Or maybe I'm wrong. Notice how it indexed the other side. It's going to do a helical entry and cut our pocket for us. So we don't really have time to go into the drilling cycles and all that, but it's pretty much the same thing. You would select a tool path, mill tool path, go into drilling. At that point, you could go through and select your holes. It's just something that you can play with. We got just a little bit of time left to, let me just post this really quick. Talk about puller milling. A little coffee recharge. Let's see, overwrite. Yep. Let's see what our whole code looks like here and see if it triggered the... See, we would just have to know that if this was running backwards on our machine, that we would have to change all our Y pluses to Y minuses and all our Y minuses to Y plus. It's not unusual to have a problem like that. That would be something that I'd say, hey, QTE, I really need these values to be right. So let's see, what I wanted to see was where it's putting us on C axis. So here we're at C0, the next C value will be 180. So all that work of setting up our plane manager, going between the two different plane managers, that's what triggers the rotation of the part. So it's kind of a crash course in how difficult it can be to program live tooling on a 4-axis lathe, but these are relatively simple contours, and I didn't practice this one, by the way. I know I can make it do it, but it might take me all afternoon to figure it out, and so we don't have that kind of time. It's something that you can play with. I can guarantee you that somehow you would have to chain this feature. What I would probably do is create a chain based on the solid geometry that goes around this part. But when you get down to, it's kind of like engraving on the ball bat. When you get down to axis control, this is now going to be a guessing axis substitution. And then you would have to tell it what the diameter, that's just a hunch. A lot of stuff that I do in Mastercam is just like trial and error and see what you got to know what the post is supposed to look like. Or sort of, at least. For the mill class, I output a Heidenhain post, which is real different, and I understand about 80% of it, but that doesn't stop me from programming a 5-axis mill because of the Mastercam tool. So it's a valuable tool to learn, and if you don't have access to a Mastercam class, it shouldn't stop you from learning it. I started, all of my knowledge is just from fiddling around with it, learning it by outputting stuff at school and just tinkering with it. But also, there's a valuable resource on the internet that is called caminstructors.com. They actually have some videos on YouTube. But what I did, you can take the Mastercam University. I wasn't as impressed with that as I was with the Mastercam Cam Instructors. You can just buy a textbook, online courses, and you don't have to take their online course. You can just buy a textbook, and they will give you a free year of Mastercam Home Learning Edition. I haven't looked at this in a while, but I think you can just buy the books, and I think the books range from anywhere from $60 to $120 or so. But for me, learning Mastercam was not an option. I wanted to learn it, so that way when I go work for someone, I can say, "Hey, I can run Mastercam." So it's a big selling point for your career and your future job hunting. So notice all this fancy code here. It does have a tendency to output some pretty huge files. So I'm going to save this. Save for next time. I might tinker with doing this rotary thing here and maybe the drill cycles, but I'm probably more interested in learning reviewing the polar milling right now, and then we're going to have a look at the first polar milling project, which is polar milling project right here, which is what we're actually going to do for a programming project. Can link a new tab. So this is actually the project, and it's really pretty easy once we kind of discuss. I might just kind of have you guys program this and see what you come up with for lab time. You can call it homework, but technically we're supposed to have 3 more hours of lab with each class. So a couple of you guys got a good running start at this, and I said, well, maybe hold off till we talk about it a little bit. You can see that this circle is off center like a cam. So there's just no way to turn this in a spindle. You have to use polar milling. This is the only option here. One cool thing about polar milling is it only uses the x-axis and the c-axis to make all these cool features. And it does that by calculating what the angular moves would be to essentially cut a square feature or a hexagon or an octagon. And you basically just program the actual numbers. All right. So the good example of this is right here in your live tool for lathe training manual 2004. It's kind of old, but it still applies. And one thing I will say, and I probably said it last week too, is these codes apply only to Haas. But the other machine tool builders have similar codes that do the exact same thing. They're just different. And I don't have an Akuma program handy, so I can't tell you exactly what these differences are. I know instead of G112, it's like G175 or something like that. There's three of them. One tells it y-axis, one tells it c-axis or Cartesian to coordinate. And so it's pretty much the same principle. It's just different codes. Now, if we kind of break this down, we're basically going to come in, mill this square with these radii, and come out. And we're not going to technically be using the y-axis, even though it programs y-axis. I remember with our Mori C keys, instead of using Y, it would actually use C on the vertical features, which was a little less confusing. I really feel like students walk away from advanced lathe class not really understanding this concept all that well, and they're thinking, well, I'm programming y-axis, and unfortunately, since we don't get to see it run, maybe I can find a example. Polar milling on a lathe. Maybe see it running on YouTube. Program it. So cutting a square on a C-axis lathe. No, that's not what I wanted. Live tool drilling. No. I'll find one. I said I'd find one this week and I forgot. So basically what we got here, program 00151, and we're milling a 1-inch square with half-inch radius. Or I guess these are quarter-inch radii. So there will be a quarter-inch radius, and that means there's a half-inch between them. So let's just break it down. We're rapiding, turning off any kind of tool nose compensation. Well, now G41 and G42 turns into cutter radius compensation. So they're going to be programming the exact tool path, which honestly isn't the best way on the lathe. The more you have to compensate, the more the machine has to compensate for the exact geometry, the more chances of error that are going to fall into the thing, or the actual geometry. So you guys remember G53 is machine coordinate positioning. So when we tell it G0, G53, Z minus 5 inches, that's going to be 5 inches from Z home. If you told it Z minus 5 inches from part home, that's going to be a pretty nasty crash. So because we're telling it G53, it's from machine tool builder home. It's a hardwired 0. And G53 is modal. So that's why they have to tell it G53 each time. Once it reads it, it goes back to reading. They didn't really call out G54 or G55, but it'll go back to reading. Oh, they're using G59. That's great. G59 is pretty much the same as G54. It's just a different work offset. Nothing special about it. So they told it G53X0, that's still machine home. And they're doing that for safe tool change position. So M1's program optional stop. We're going to call up tool 101, which is our 3/8 diameter end mill. M154, some of these codes should start kind of looking familiar to you right now if you've been doing your lab work. Engage your C axis, G28H0. So this is incrementally, with the H is incremental for C. So we're incrementally taking the C axis home. And one reason we would use H instead of C is because it does it in the quickest way possible. In other words, if C happened to be sitting at 270 and you told it G28C0, it's likely going to rotate 270 whole degrees. Or if you tell it G28H0 or incrementally go home, it will just, I would say likely, rotate the 90 degrees instead of the full 270 to get back to home. So if you remember, we have a different M code to turn the spindle on. And instead of an S value, it's a P code or a P value for 2650 RPM. All right. So now instead of G53, which wouldn't be active anyway because it's a one-shot code, we're in G59. And we're going to wrap at 150 in front of the part, still at machine X0, and at C0. So I don't know why they tell it G59 twice here. You wouldn't have to because G59 is modal. So they're going to wrap it to X0 and Y0. Kind of surprised that they didn't move off. Oh, they're making it. This is a pocket. Okay. That's a pocket, so it'd probably been helpful if they would have made it an external feature, because if you are working on an external feature, you would wrap it off to the side of the part, which would be the diameter of your part plus the diameter of your cutter. All right, and we should probably go over that one more time when we talk about the actual lab work. So this will kind of get you in the mindset for the final here in 2 weeks, just writing a program from start to scratch. This will be a great copy paste, and then you can just change the geometry. All right, so notice we're going to G98, which is inches per minute, not inches per rev. So you got to kind of tread on thin ice when you're using G98 and G99 on the lathe, because you don't want to be telling it that you're in inches per rev and tell it to go 4 inches per rev, because that'll be a crash. So G17 is XY plane. It's one of the few times we actually use G17. 2 times that are on the cheat sheet are for G112, which is our next command, and X and Y axis milling, which would also be what we're doing here. So it's about the only time we're going to use G17. Now G112 is that magical code. It's one of the most magical codes in CNC because it says, now I'm going to don't think interpolation, think interpretation. I'm going to interpret your X and Y axis moves into arc and degree values. So we're really just, again, moving C and X. If you can imagine the C rotating one way, pretty much into the cutter while X moves in and out. So we're going to feed into Z minus 0.075. Must be a center cutting end mill. So we're going to G41 X.5 F11.25. Notice they don't give it a D value here. I'm guessing that once you pick up the T101, that is sufficient. So we're feeding over to X 0.5. So this is 1 inch. We're feeding from center over to X 0.5, which is right here. Then we're going to feed up to Y 0.250. So again, you've got a 1 inch width all the way around from center, 1/4 inch radius. So from here to the top, you got a 1/2 inch. So half the radius would be 250, and the rest of it would be another 250. So that's why we're at Y250. And this is good to review circle cutting because the final has a circle cutting on the lathe. Same principle. We'll review that next week. But G3, circular interpolation, counterclockwise. So just like an analog clock, we're feeding to absolute positions. Notice they are not, okay, they're not giving it a Y value. They should be. So we're feeding to X 0.250, which, if you were putting dots around this geometry where the start and stop points are, it would basically just connecting the dots. So X 0.250 from center, Y 0.5 from center. So this is a point that when we're doing polar milling, we're no longer on the diameter on X. So another one of those wonderful rules about lathes that everybody loves so much. So Y 0.250 or Y 0.5 with a radius of 250. Next move is X minus G1. I remember G3 is modal, so it will continue to cut circles until you tell it to cut straight lines. So from here to here is a G1 X minus 250 because X is on the minus side of 0 here. Still G3 going on around. X minus 0.5. Now, even though the cutter is over on this side of the part, you're still programming the exact geometry. So X minus 0.5, Y still plus 0.250 with a radius of 250. And then we're going to feed down to Y minus 0.250, G3. All these values are absolute from the very center of the part. And they just kind of go on around. Now, this last G3, X 0.5, Y minus 0.250, wish I could draw this bigger on the board and make little points where all these intersections are because it would be a little bit easier to see. Once they get past this last radius, notice they're feeding up to Y0. That's kind of the big trick about manually programming the C-axis features. If you're going to start, if you're cutting a pocket, you got to start in the middle, move over to your X value, and then move around your contour counterclockwise. If you're programming an external contour, which we will be doing, you'll start on the outside, move in, and then cut, clockwise, because you'll be climb milling around your contour, and then wind back up at X and move out. Okay, so G40 out, and we're pretty much good to go. So we have a little bit of time here. Let's at least get started on the program, and I can sort of give you some ideas of what lines you're looking at and so forth. So I'm going to start a new notepad file. And just going to go ahead and save this, save as. And it's nice that it knows I'm not in mill. Let's go to advanced lathe operation. S20, because this is pretty, you guys are special. This would be polar milling. I'm going to call it polar milling lab instead of homework. It sounds way better. All right, so now I've got a place to start here. I'm going to need going to need my drawing, and we'll probably want to, let's see, I'm going to close out a YC. Don't need that. Some of you guys need it. Need to finish it up because it's hard to really move forward until I can kind of see where you guys are at with this information. That, the lecture is good and all, but until I start getting feedback from you and giving feedback back to you, that's where you can really solidify the information with assessments. In fact, I have to do an ESO on this class, which is an expected student outcomes. And my job is to determine what your student outcomes were from this class, and also verify who all prevailed, not names, but and also what level of assessment do we use to achieve those goals. So it's a big deal. It's the Higher Learning Commission, and try to put a lot of thought into these classes. So you gotta give me some feedback. All right, let's look at this part. These are not pockets. These are bosses. So the difference between a boss and a pocket is boss is. I had this one die maker that I met at Lake City when I worked there for a few months, and he would call it proud. So a boss is a proud feature because it is sticking out from the part. We're not cutting pockets. So we'll come in from this side and mill our feature going around this way. So the thing is, each one of these features is 50 thousandths deep. So the smart thing to do would be to come in here and mill the shallow feature first, and then we'll mill the second feature, and then we'll mill the third feature. And each time we want a G40 out. All right, so what I'm going to do is I'm going to try to be a smarty pants here. I noticed that this was allowing me to highlight today. Seems like some days, come on. Seems like some days it will and some days it won't. All right, I'm going to copy. Oh, it's just got to save as. That's fine. Repetition equals knowledge, man. All right, so we're going to go Shift%, and we're going to name this program 046231. Don't ask me why. It just came out that way. Control save. And I'm going to say this is going to be my S20 polar milling lab. Sounds way better than homework. Pretty much more scientific. Control save. All right, so we're not going to worry about turning this part. We're going to have a thorough turning review next week. I'm going to just pull up the final and kind of look it over and give you guys an idea of what to prepare for. If we do have homework next week, it's not going to be a ton. It might be, something to help you prepare for the lab or the final. All right, so we're not going to use line numbers. Some people will use a line number for each tool, and that's fine. I don't see any value in that. So my style of programming, kind of like old Bob Ross, says, your world. I've been kind of watching Bob Ross lately to pass away the hours of sheltering in place. 12 milligram melatonin and 3 episodes of Bob Ross. All right, so M1. I'm not going to use that M1 there either because I got this designed as being kind of its own dog toolpath. It's not like a whole program. So you can put a safe start line here. And there's plenty of examples of that in different programs we've written. Things like that. Safe start line. Now, one thing, I got to remember to upload this because on Mill Class, I completely forgot all about it until Friday. So we'll say P1 No, we're not going to do that. Yeah, T101. T101. This is going to be, we're going to make this a 1/2 inch mill. And we're just going to take one pass around our part for just ease of programming, because a lot of times you'd want to take some roughing passes, etc. I'm going to kind of follow my example here a little bit. Now there's different ways to bring your tool down to a clearance plane, but this basically right here, they've got a, they're moving the machine to a safe start place, so we could put G28. And this, we'll call up our finish mill. One thing about this is they don't really talk about it here, but for this to work, when you call up this G41, it's going to say, I'm going to go pick up whatever diameter is in the registry for tool 1. So it's on the setup guy. When you set that tool up, you'll take a Z length offset. You'll take an X offset. If you kind of review in your memory how to do that. Also, that reminds me, I put out an announcement about potential for lab time coming up after class is over already. I don't know how much of that I'll be involved in. I would be willing to go down for maybe 1 week of our regular class time after the course is over. It's not going to be a requirement because I don't want to pressure. And there's a lot of different attitudes about what's going on right now with the coronavirus. And I don't want to make that a requirement. Plus, MCC is not even sure if they're going to be able to get her done to allow it to happen. So what the Mike Klein wanted us to do is take a poll of all our students who would be interested in having lab time somewhere between May 15th or 1st and 25th, I think. It's in the announcement. So if you could just send me an email, I don't care either way. It's not going to make a difference to me. But if you're interested or not, just send me an email about what your thoughts on that are so that I can get back with Mike on that. All right. So we're going to say M154, just like the thing, just like the example. And I don't need to type out what that means. We're going to zero out the spindle, G28. One thing I will say too is sometimes the lathe will have a C axis and not a Y. The reason I say that is you could easily mill this with the Y axis. The reason you wouldn't want to is because you might have one lathe that has a C axis only, or you might have another lathe that has a Y axis and a C axis. You'd want this program to be run on either lathe. In other words, you won't have a lathe that has a Y axis and not a C axis, but you will have lathes that have C axis and no Y axis. So you always want to program to the lowest common denominator on your shop floor. So G28H0, and we'll say M133 P. So this is turning on the RPM for the cutter. That might be kind of fast for us. We're cutting steel. So let's just run let's just have a little quick review of the surface feed calculation here. So 3.820, remember that's 12 divided by pi, times whatever surface feet we would like to run, which I'm going to say we got a carbide end mill. It's going to be about 280, 290, divided by 0.5, which is the diameter of the thing. So that's 2,200 RPM. Not too far off. We'll just say 2,000, 2,100. And so the M133 is like an M3 for live tooling. Just have this little special code. Okay, so we're going to be in G54. You can put your G54 in your safe start line. They're using G59 again. It's just a different offset. It means nothing. We set ours at 0 anyway. All the positions from machine home are based on where the tool is, and we would use our offset to maybe move Z back globally to watch something run. It moves all the tools. All right, so I'm going to say G0, G54, Z 6.0, clear the tailstock alarm for some of those larger Haas machines. And then I'm going to say X. Our part, we'll get you started on the right foot here. We'll just say we've already got it turned down. You can add the turning cycle in for practice if you want, and then I can make sure you got that. Yeah, let's just go ahead and make that OD turn part of it, because I want to make sure you guys are understanding that for the final. Add, oops, OD turn cycle. Oops. I'm used to typing on a full-size keyboard now, even though my typing is still crappy no matter what. Based on a 2. So R1.1, it's not a great way to dimension that. It just came out that way in Autodesk Inventor. So 2 of that would be 2.2 based on 2.250 material. All right. So where we would wrap it down is the diameter of our material, which is 2.250, but we've got turned down to 2.1. I would err on the side of saying, hey, my tool broke when I walked away, and I want to make sure that when my end mill comes down that it's not going to crash into the part because my tool broke down or is gone. So we're going to say 2.250 plus our diameter of our 1/2-inch finish mill. Remember, when we would take offsets, we take the diameter of the mill plus the diameter of the part, because everything is based on X center still at this point until we turn on G112. So it's going to be 2.250 plus 0.5, which is 2.750. Let's give it another 200 for good measure, plus 0.2. So we're going to wrap it down to X 2.950, Z 0.1, M8. Turn on our coolant. Okay. And we also want to make sure and turn on G98. So I'm basically just copying this first part of the program that is important. G17 is important. Seems like you could turn those on in separate line in the same line, but since they're not, I won't. All right, now we're going to give it a G112. And that is going to do our magical XY to XC interpolation. I like interpretation. And our Z value is actually now going to be Z minus 0.050, because each one of these depths are 50 thousandths. E1 Z minus 0.050. Okay, so since I've got live tooling turned on and everything's turned on, I can go feed over to G41 at the start of my circle. So G41 X, and this is something that I would like for you guys to calculate with your lab time, is calculate the geometry. So what you got here, this represents your center point. Remember, now that we're in live tool mode, all these X and Y values are based on how far it is exactly from center. All right, so when we're looking at this part, you've got an 850 diameter hole or circle boss. And from the center of the part to the center of the circle is 250. So what does that tell you? I'm just going to give you a little hint. You really care about what it is from here to here, because this is going to be your start point. So it's 0.850 being the diameter of the circle, divided by 2 is 425. So you know that from here to here is 425, but you also know that from here to here is 250. So your start point is going to be X plus the difference between 250 and 425. Okay? Then you're going to have to cut the circle, and it's going to be a climb milling feature. So that's going to be, let me put a couple enters in here to get this up a little higher. And you'll say G blank, blank, blank. And since we're going to cut a full circle in X, we're going to say G3, oops, I gave it away. But it's not G3. So that's going to be an I value, and your I value will be the distance from here, from your start point to the center of your circle. So you got to calculate what that I value is and whether it's plus or minus. Now remember, you can submit the work until it's right. It's best if you submit it earlier than later, and that way you have a chance, because I don't just tell you what the answers are. I will give you a hint. And I'd just like for you guys to really think about this. All right, so that will put you back at the front of the circle again. So those two lines, you're feeding in G41, cutting your arc. Then we're going to G blank, 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 G blank, 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 X. So that will be feeding back out to your clearance plane. In fact, I'll give you that one. X2.950. So you're going to have to pull it out of circular interpolation, and you're going to have to turn off your tool radius compensation here and feed it out. So each one of these contours, you have to turn the comps on, turn the comps off. So then we'll say Z minus, still on the feed rate, dot, dot, dot. And then you'll say G41 X. And that will be feeding into the next contour. So you'll be deeper in Z, which is reflected on the drawing. And at this point, you will mill the hexagon. And you just, since you're in G41, you can program these exact points. So with this hexagon, you got a 750 width. You might have to trig out what the points are on the hexagon. So if you don't have a trig app, you might want to download the trig app. Basically going to be, I think I have one. There's one on the internet. Trig calculator. That's the one I've actually visited before. So I never clear my cookies. Let's see. Trig app. Where was that thing? Triangle calculator. I know there's one somewhere. Carbide. Here we go. This is the one I'm thinking of, I think. There's one that you can find that actually has a picture. Here it is. Angle A, angle B, angle C. So let's put. So if this is 750 and it's six-sided, you'll have to figure out 750 is half the width of the triangle here. And then you can use that width. You got 1, 2, 3, 4, 5, 6 angles. So it's basically, this has got to be 360. So 360 divided by 6 is 60 degrees. So each one of these is 60. So half of that would be 30. You got 30 degrees here and 3/8 on this side. So you go back to your trigonometry calculator. Side A, or angle A, is 30 degrees. And then side A is 0.375. So let's see. It calculates the rest of it for you. So that means side B is 649.5. So you can write all that down and plug those values into your points, and those would be your points off center. So I'm going to have to do that myself so I can grade your work. And if you need a little help with that, we can work through that with you. But then that would be program hex point. And then we'll G40 out. G dot 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 G40 X 2.950. And then our next one would be the square, which is another Z move to the very bottom. C blank blank blank. And then we're going to say G41X, which will be moving. The square is a little easier. Now, you can't count on the hexagon being the same width as the square because it's not. In fact, I think it clips it a little bit. But this 1.609, this will be a little easier. Pretty much, it's just like programming the square in this live tooling, except there's no arcs to worry about. It would just be the 1.609 divided by 2, and x and y. So this side would be your x plus 804, y plus 804. Wait, we're going the other way. X plus G41, x 0.8045, y minus 0.8045, x minus 0.8045, y plus 0.8045, and then x minus 0.8045, and then to y0, and then out. Dot, dot, dot. And then we'll program square. And then same thing. Copy and paste. And that's that simple. Rapid home, take tool, home, and end program. So that's probably a good couple hours of lab work. I mean, if it were me, I'd have to sit down and do a little math there. Okay, so I'm going to go save that. I'm going to close it out. I'm going to make this full screen. And then we'll go into, we're going to upload that right now. And this is all the, if you're wondering where the lab work is, it's under weekly homework. Build content, file, and it's going to be Polar Mill Lab. Problem on computer. And still thinks I'm in CNC mill for some reason. Advanced lathe. There it is. Boom, done. So now I don't have to worry about remembering how to do it, or remembering to do it. So I should be able to click on that and see that little bit of programming there. Should be a little bit bigger when you're done with it. So let's see, does anyone have any questions? So we got a pretty small class today. I appreciate you guys popping in. Any questions? All right, I guess it's 10:01, and class usually runs till 1, so you have plenty of time to finish up the lab homework. And I hope you guys had a good class on Saturday morning, and we will see you guys next week. I guess I'll see Blake on Thursday. That's all I got for you. I'll I'll publish the video on UJA, and then I'll upload the recording into YouTube. Yes, Julali, you have a question? Oh, no? If you do have questions throughout the week, as always, feel free to text me or email. If you want to submit your programs via email. Again, does lab start? Well, lab kind of starts now. Like if you don't have to do it now, obviously. Just be great to have it by next week, and because next week is pretty much review for the final. We might have a little bit of lecture, still be a 2-hour class, and then the following week is going to be just the final. But maybe you're asking about the lab. Let me pull up my. Oh, I know. I've got the announcement in the Blackboard. I don't know why that bar turned that color on me. So if you look under announcements, this is not my letter. This is from the office of Mike Klein. There's potential time frame that BT campus may be able to open for small group, 10 or less, from May 1st to 27th. Now our last class is, go back to my calendar. Our last class, I got it in a weird mode here. There we go. Last class is May 9th, and I'm not having class down at the BT. I think that, to try to do that at this point would be sort of helter-skelter. And we'll just finish off the class. We only got really one more session next week. And I think that, but that said, if you want to go down there and work on the machine tools in your own time and just for your own knowledge, just maybe set up and run these programs that we've been working on, or try something yourself. I think they could arrange something where Eric was down there. I would be willing to go down there the Saturday after May 9th, after the last week. So if they can do it, they wanted to know how many of students were interested in that. I told them I felt like it would be a very small amount, but I could be wrong about that. So I would be willing to do a Thursday and a Saturday for anyone who's interested. I will ask Dave Grady about that. Um, yeah, and get back with you. I kind of doubt it, but I'm kind of interested in that too. But so are you saying that you'd be interested in having lab time if the Akumas are set up? Either way. Okay, so you're in for lab. I'd count you as one person who would definitely want to. I know that there's probably Joe Engelman in the middle class who would probably come down, and even if it was one person, I would go down the first week after school. So I mean, I'm kind of planning on being down there for that, and if anybody shows up, fine, you know. So again, if you have any questions during the week or anything, feel free to call me or email or text, and I will check with David Grady this afternoon about those Akumas. So I'm going to